I'm the one to drive versus Barrasa, so I'm part of the field team with Neo4j, and I've been, among other things, been spending some time on this plugin called Neosemantics that does this integration with RDF and Neo4j. And with me today you have Adam. A quick introduction.
Yeah, so my name is Adam Cowley. So I work with Jesus as a field engineer in the professional services team for about 2.5 years. And in the last few months, I switched over to be a member of the developer relations team. So I'm now a developer experience engineer, working to try and make your lives easier, essentially. Excellent.
And we're going to show a bit of the the work we've been doing over the last few weeks, and back to the title. So what we're going to, we have released only a couple of weeks ago Neosemantics 4.0, compatible with Neo4j 4.0, and with it, which is the brand new thing, we have Adam has developed a great graph app that we're going to show today. But I think that the plan is for me to give you a quick introduction, especially for those of you who might not have Neosemantics before or RDF, and then we will go hands-on and we'll take you over the new stuff and how to use it from the app. So let me get started by saying, well, Neosemantics is one of the labs projects. So the DevRel team has a number of them. It's kind of an incubator, and most of you will be probably familiar with projects like APOC or the Streams library. I know this probably can remind me of some others, Adam. But these are kind of extensions to Neo4j basic capabilities, and in particular, Neosemantics is about integrating with RDF. You probably know that RDF is a model for data exchange. It's a W3C standard that represents data as a graph. So what we will make really simple, you're going to see that in the second part of today's session, is to import data that's represented, that serializes RDF, push data out of Neo4j in the form of RDF, and do many other things between these two. So if you go to the labs page, neo4j.com/labs, you'll have access to all of these projects, and in particular the Neosemantics one, have the URL there. You'll find there links to all the elements that you see here. So you'll have, of course, the source in GitHub. Contributions are more than welcome, of course. You'll have a link to the manual. You will have lots of resources like blog posts that I've been writing myself, and Mark Needham and other members of the team. And from now, you also have access to the new graph app that we're going to be showing today. So that's your kind of the home page for all things Neosemantics. So I've already mentioned it a little bit, but what Neosemantics does is enable a number of integration possibilities with RDF, and the two basic ones are input and export, right? So there's a number of data sources out there that publish data in the form of RDF or Sparkle endpoints. So what we will show is that Neo4j can store that data in a lossless manner. So you can basically import triples and then be able to export them back if that's what you want to do, or maybe you just want to keep them in the graph as a way of enriching your knowledge graph. There's many options, but you can import RDF data, and you can similarly export RDF data. Again, RDF, as we were saying, is a serialization, is a model, is a way of serializing graph data, and you can expose or export your Neo4j graph as RDF. Sometimes you will want to do things, and we'll cover all that today, things like mapping models. So I don't want this RDF model to be stored exactly as it is in the source. I want to apply some kind of transformations. I want to map it to my schema. Or and there's some new stuff that we're quite excited about, which is validation, data validation. So there's another W3C standard which is called Shackle. That's a language for defining model constraints. You will be able to specify things like, I want nodes of this type to connect to nodes of this type through this particular relationship. So it's kind of a way of defining what your graph should look like. And you can run validations based on this constraint using Neosemantics. I think we'll have a look at that as well. Probably won't touch today on the inferencing capabilities. It's pretty limited and it's kind of work in progress, experimental, but that's another interesting area as well. So very briefly, it's implemented, Neosemantics is implemented as a set of procedures, so you can use them from Cypher. Because we're going to see it, I will not spend time on that now, but you will find things like, I want to import RDF, so I'll have a number of procedures that you see they have this kind of structure, RDF import, fetch or inline will let you either pass the RDF as a parameter or when you use the inline option, or fetch, just retrieve it from a URL, whether that's querying a Sparkle endpoint or just getting a document. So this is the import procedures. There's a whole bunch of parameters. You can tune many things in this import process, but we'll do that all through the app. So this is a link to the documentation. You have a whole reference of all the possibilities. We'll look at some of them now. And yeah, we're going to try it, but let me, in the end, we agreed that I'll cover my slides briefly and then we'll do all that in one go. So that's for the import part. From the export part is implemented as a managed extension, which means that Neosemantics creates an HTTP endpoint on your Neo4j instance that you can query, and you can use it to run a number of operations. We're going to show describe, but you can run Cypher as well and get the result of your Cypher query serialized as RDF as well. So basically, you create an RDF endpoint on top of the Neo4j, right? And you have a number of functions. I mentioned describe, which we'll see today. There's a find function, and you can run Cypher or expose the ontology of your model. Again, we'll try that. And finally, there's the possibility of mapping models, and these can work in two kind of phases of the process. You can do model mapping when you're importing data. So you can say, I want to transform this RDF and use that particular type as this label in my graph, or I want this property to be renamed as this other one. So you want to apply some transformations. So that's the import phase. But you can also apply it on the output phase. So you want to say, I have a graph already. I've not imported it from RDF. It's just the graph that I had in Neo4j, and I want to publish it, but I want to publish it according to a standard vocabulary. Let's say, for example, a schema, or you can define mappings again. You can say, when you expose this node that is a customer, well, you're gonna do it saying that is a customer according to schema.org. So again, this mapping works in both directions. Good. And there's a number of methods and procedures and functions that will help you defining these mappings. But again, we'll see them through the app, which I think is going to be a lot better. Let me take a break here and probably hand it over to Adam, because I think we'll share the deck. So and there's of course the documentation, so you can see all these options. Let's probably see all these things in action from the app. Shall I stop sharing, Adam, and you can take control?
Yeah, sounds good. Cool, thanks, Jesus.
No problem.
Cool. So I guess the main thing for your side to note on this app is that this app makes your documentation completely irrelevant now, because it's all there and it's so easy to use. So for all of those people that haven't come across this before haven't come across the term graph apps. So graph apps are a single page application. So they're written in JavaScript or the front end framework of your choice. And what they do is they extend Neo4j Desktop. So on screen right now, I've got Neo4j Desktop. So if you've been to neo4j.com, click download. This will be what you would download. And essentially, it's just a UI that allows you to manage multiple projects and multiple databases. So the Neosemantics graph app is an extension of Neo4j Desktop, which just allows you to explore the library and to read RDF data essentially in Neo4j. So inside Neo4j Desktop itself, on the left-hand side, we have this graph apps pane, and this is where all of your graph apps live. In order to install the Neosemantics graph app, what you can do is you can open up the graph apps gallery by clicking the open icon, and then there's the Neosemantics listed here. So all you need to do is just to click to install, and then it will go away and install it for you, download everything. If there are any updates, if you install this way, then they'll be updated automatically as well, which is useful. Great, and if you're interested in more information, there's some more links on the Graph Apps gallery, so you can look at the code repository. So the app itself is built with Vue.js, so you can view all of the code there. I wrote an article on Medium about how I built it, some of the design decisions that I made, or you can take a look at the docs. So once that has been installed, you can see it's listed here. So I can either click on the open icon here, or I can do Command and K on Mac or Control and K on Windows, and then start to search, and then that will allow me to open the app. So one thing I want to do inside desktop is to first create a new project. So I can do that by clicking New, and then, for example, I'll call this Neosemantics. Now create a new database with the latest version of Neo4j. So that'll go through and that'll create that. So now what I can do is I can open up the app. The first time you open up the app, you'll see like a login form. So what this will allow you to do is you can either search for a project and then a database to connect to. So for example, if you had a remote database or a Neo4j or a database that you had configured inside Neo4j desktop, then you could select that. Or you can just click Active Graph, which will then connect to the active graph. So you have one active graph inside Neo4j desktop at any one time, and that's denoted by the colorful button here. So once that starts, and the status as well. So now I can see this is the active graph. I can just click Active Graph and connect to that. Cool. And then because it's the first time that I've used Neosemantics with this database, it will give me some instructions to install the database. So for example, it's saying that there's a plugin required. So what I need to do is I need to go and download that from the releases area. So essentially what you do is you take the jar file, which I've already downloaded. Downloaded here. And then click on the three dots in the top right-hand corner of the card of the active database and click Manage. And then this drop-down next to Open Folder, I can open the plugins folder. I copy the jar file into there. And then what I need to do is to restart the database in order to activate that. There's also an extra piece of configuration that you need to do. So essentially what this line of code does is it mounts the Neosemantics procedure to a HTTP endpoint on the Neo4j server. So you can essentially for exporting the data from there. So if I go into my Neo4j config file by going to the Settings tab, and then stick at the bottom, and then save that, and then restart the database. And then once the database is restarted, then the plugin will be active. It normally takes a few seconds, so talk amongst yourselves. Great. So once that's started, and you're looking for the remote interface available inside the log files. So now I can click I've installed the plugin, and then I'll go through to the next stage. And this is a bug in the UI. Sometimes I need to click that a few times in order to get it to work. So the next thing you need to do is you need to create a constraint. Jesus, I've not quite understood why you need to do this yet. So can you give me background on that?
Absolutely, yeah. Well, the thing is in RDF, resources, which is the equivalent, of it's probably a general term, but we can translate that into probably nodes in a graph, are uniquely identified with a URI. So what we're going to do is we're going to make sure that when we import data, potentially from multiple different sources, if they have the same URI, they're going to be merged into the same entity, into the same node. And as a way to make sure that we don't have duplication, we create these constraints. It's just a safety measure. All the procedures, take care precisely of that. But it's just to make sure that there's, and also, it creates an index which will accelerate, the lookup of resources nodes by URI. So basically, it's we're making sure that the URIs are unique and that they're backed by an index to make it run fast in the queries.
Okay. Yeah, cool, makes sense. Yeah, so all you need to do now is to click create constraint, and it will go away and create it for you. So you could either click that button, or you could go away and you could copy that code and paste it into the Neo4j browser in order to open that. So once you've done that, all the checks are complete, then you've got this application. So inside this demo today, we're going to be working with a data set that Jesus has put together today. And so essentially, I mean, this doesn't mean too much to me, but to anybody watching that is familiar with RDF, then this
let me quickly. I mean, I think what we were discussing just before the streaming that it would be a good idea maybe to kind of reproduce what a working session would be with Neosemantics, right? So, like Adam says, we have a data source. I mean, for this session, I've created a very simple one with a few triples. With the music data, if you can read Turtle, which is this particular serialization of RDF, you can probably see that there's information about two bands. There's a band called the Beatles, you might have heard of them, and another one called the Rolling Stones. And it has a few properties. I mean, it has the name and bands are linked to the members. Then there's also album information. So albums have the title, some information about the release date, etc., and they link to the tracks, the authors. Well, it's a pretty simple data set. We're gonna be able to visualize it in a minute once we have it in Neo4j. But the idea with this session is, okay, we have a data source in RDF, right? Make it simple for now, and it leaves all in a document. Maybe in another session we'll look at how to query Sparkle endpoints. But for now, we want to import that data in Neo4j, right? So probably we will go through several steps. We will want to maybe see what would that look like as a property graph, right? Because there's some kind of transformations. And maybe I want to tune the way this graph looks like when it's imported in Neo4j. So that's exactly what I think we're going to try to simulate, right, Adam? So we're going to set a default config, see what it looks like, and then modify it as we go.
Yeah, absolutely. So what we can do is we can take this file, and so as Jesus said earlier, one of the methods that you have is a preview method. And there are two ways that you can use the procedures inside Neosemantics. So you can either you can fetch the records, or you can use an inline representation. So you can essentially copy and paste into a Cypher query. One thing to note as well while we're looking at this screen is that with every one of these screens where there's a procedure, what we'd like to do is to educate you how to use it, educate the user how to use the library, as well as just sort of importing the data in. So anywhere where there is a Cypher query running in the background or a procedure running in the background, there's a preview tab. So you can see based on the form, it will update the Cypher preview as you go. So in this example, I can take the URL of this file. I can fetch it from the URL, which then essentially uses this fetch method to find it. I can paste in the URL. So this procedure takes two parameters. So the first one is the URL, and the second one is the format. So we have the URL of the turtle file, and then the format itself is turtle. So the library supports quite a few formats. And then what we can do is we can either preview as a stream, or we can preview in graph view. So if I preview it in graph view, for example, okay, so we've seen now we have some issues here because we don't have a graph config set up yet.
Yeah, that's great, and it's a good warning. So the thing is, one of the things that have changed in version 4, and this is probably more for the people who have used Neosemantics in previous versions, before every single request, like every import or preview request like this one, would contain, in addition to the URL and the format, a number of parameters with all the settings. Now what we're changing is we're going to persist that. So we're going to set it at the beginning. We're going to say, well, that's what my graph is going to look like, and we're going to see in a minute the kind of things that we can define. And this configuration is going to be persisted across requests, and that will make the whole session much more understandable, because you don't have to stay consistent with all these parameters every time. So yeah, if you try to run it and there's not a configuration, it will warn you. It will tell you, hang on, you can't do that before doing that. And yeah, that's I guess the next step, because now it looks a lot easier, right? Now you have all the options listed in the app.
Yeah, absolutely. So for each of the options inside the configuration, there's a drop down so you can build up the form. So what you can do is you can run n10s.graphconfig.init just on its own, and that will create a blank config with the default values, or you can use the form to build one up. So for example, here we have the handle vocabularies, which is going to be sort of important a little bit further on in the demonstration. So Jesus, why am I using map here?
Sure. Well, this is one of the key things because I mean, by default, well, let's think what we want to do here with the graph we input. So the handle vocabulary URIs is about, do I want to persist the unique identifiers of things in my RDF data? So as I mentioned before, everything in RDF is identified by a full URI, which is a global unique identifier. Well, that might be useful if you want to be able, for example, to regenerate it afterwards, or if you want to keep a reference to that unique identifier. So it's really up to you. So you might say, well, I want to make sure that I want all these RDFs that I'm importing, I'm going to be able to then regenerate it for interoperability of all sorts. Or maybe I don't. Maybe I want to ignore it. So this is precisely what this property defines. So you can, by default, with shorten, what we do is basically we associate with every long namespace. You probably have seen some of these URIs, but Neo4j does not have a native way of dealing with URIs. So what we do is we create prefixes in Neosemantics. So we're going to shorten this long name with meaningful prefixes. So that would be the first option. So that's a way of making it much nicer from the point of view of the property graph. We're going to be able to query it because the names will look much more compact, but we still can regenerate the original RDF. So that's the default option. But in some cases, you probably just don't care and you say, all I'm doing is I have this public data source and I want to import some data. It's just to enrich my knowledge graph, but I have no intention of exporting it afterwards. So you might say, I want to ignore it, right? Or I want to transform it on the way, as I was saying. So we might want to apply some mappings and rename some properties, rename some labels, some types. So that would be the map option there. And finally, there's the keep option, which would keep the whole URIs. That will make pretty weird from the point of view of Neo4j, because you will find labels with a whole URI. I mean, you can, just as for fun, you can try it. I don't know. I've seen some users in the community trying it. It's not the nicest if you want to query it with Cypher, but hey, it's there as an option. So that's what this property basically does. So I don't know, shall we try it first with shorten and then maybe define a mapping or something like that? Or we'll try the defaults?
Yeah, cool. So as you go through and you edit things inside this form, so by default, nothing will show inside the query at the bottom. But for example, if I then start to change the configuration, then it will change there for me. So is there anything there that's that's useful? Or?
Let's leave the defaults for now. But yeah, just to go very quickly over the others, and I'm not going to spend as much time as I did with the other one. So in RDF, there's the notion of multi-valued properties. So you can have the same triple, same subject and predicate, with different values as the object, which is essentially multi-valued properties. And the natural way to store that in Neo4j, a multi-valued property is an array, right? So you have two options. Not every RDF data set uses multi-valued properties. So you might want to say, I don't want to be bothered, because if you create an array, then you have to access and manipulate it in Neo4j as an array. So if your data has multi-valued properties, you might want to say there, handle it as an array. And if not, you can say override and just keep the last. If there are multiple values, well, they're going to be overwritten. If there's only one, you'll be fine. But it will be stored as an atomic value instead of an array. So that's how you handle multi-valued properties. If you choose multi-valued properties as an array, you might want to apply it to a certain set of properties, not all of them, but you can enter them there. The keep language, again, in RDF, literal values of properties can have a language tag. You might want to persist it in Neo4j, you might not. So it's an optional element. If you want, you just turn that on or off. And there's an interesting one, resources, nodes, if you want, in RDF can have, of course, multiple types, and that's stated with the RDF type property. And there's different ways in which you can migrate that to a graph. So you might use labels. There's the notion of labels in Neo4j. So one way of storing types is as labels, and that will be the first option. You might want to keep the structure and represent the type as a node, and then link all the instances of the type to it with the type relationship. So that will be the nodes option. And sometimes you want to have both. I mean, I'm not 100% convinced of that, but that's a request from the community. I said, let's put it out there and let's see how people are using it. So the labels and nodes will do the two things. We'll add multiple labels to the nodes, but we'll also create an external node and link it to it. There's custom data types, which is kind of a variant of the language tags. Is an additional way of creating your own custom data types. You can turn it on and off as well, and you can apply it to a set of properties, maybe not all of them. And finally, the last one is in the process of importing, do we want to apply the Neo4j naming? And that's basically applying the camel case, doing capitalization for relationships. It's a couple of syntax changes on the name, so that's kind of an optional one.
Mm-hmm. Cool.
Yeah, so that's pretty much it. So
perfect.
Yeah.
So yep, I can just hit create config on there, and it will create the graph configuration for me. So that creates a single node in the database, right? With all this.
That's right. That's all persisted in a node that holds the config. And yeah, it's important to understand that, of course, this determines how data is stored in Neo4j. So you don't want to change it all the time because you will end up with an inconsistent graph. So actually, if you try to change it, you will get a warning saying, "Hang on, you can't do that with a non-empty graph." So maybe you want to empty the graph. Actually, maybe I don't know if you're going to try that today, but maybe we can see. Or maybe we can do it through preview to see what the effect of this configuration is in the data that we were looking at.
Yeah, cool. Okay, so now we've created that configuration, we can now run the preview again. So again, I'll do fetch from URL, and I'll paste in the URL there. So in the background, this procedure will be run, and then the results will be returned back. So this is all of the triples. So we have the subjects in this case. The individual, the Beatles, which has a type of band, an artist, etc., etc.
Yeah, this is just a way of kind of, sometimes it can be useful to see a bunch of triples, but it literally just streams. And sometimes, the thing is, you might want to not apply the kind of standard import that Neosemantics does, but maybe you want to take control of that and use it in Cypher to select certain triples and update certain properties. So basically, these translate, like Adam was saying before, in a request that you can use in Cypher in a procedure call that you can then use the way you like, basically.
Mm-hmm. Cool. Yeah. So that is the stream, so the table view. So there's also the preview. So n10s.rdf.preview.fetch, and this will just display it in a force graph layout rather than the table format. So you can see here. So this is the same information from the RDF, but now in a property graph format. So for example, here we can see a band and an artist, which is the Beatles. So the URI there is the Beatles, and then it's been given a NS0 name of the Beatles.
Yeah, the thing there is, again, we have not set any prefix definition. So what Neosemantics will do is dynamically generate them. So we find a namespace in this dataset that Adam has just imported. There's not a namespace for it, so I'm going to give it, unless you tell me otherwise, I'm going to give it an NS0 namespace 0, right? So that we can use it internally. But we can override that, and maybe we can give that a try.
Yeah, so the namespaces screen allows you to define the namespaces and then essentially assign a prefix to them. So there's a way that you can add them using the form. So in this case, this shows you the overall procedure that you would run. So for example, you'd run n10s.prefixes.add, and then the prefix, and then the namespace. So we could go through and we could add all of those one by one. But maybe a little bit tedious. The other procedure that you have for adding namespaces is that you can extract them from text and from an RDF query. So, for example, what I could do is copy and paste this into the form. And then again, below it will show me the query that I need to run. So I'm creating a big long string.
Yeah, actually, I mean, just the header would be enough. I mean, you don't,
Okay.
but yeah, and basically, I mean, it's because normally all the namespace definitions are at the header of the document. So if you take that fragment, it doesn't matter what serialization, if it's turtle like this one, or if it's RDF-XML or JSON-LD, you just paste the header there, and it should be able to extract it and create them for you, hopefully.
Okay, cool. Yeah, so from that procedure, we yield the prefix and namespace, and then we return those. With all of the procedures before, you've just seen like a call and then a procedure name and then some parameters. That's the lazy way of calling a procedure. So this is a more complex way of calling a procedure. So if you do anything else around a procedure, and not just run a procedure by itself, you need to yield the values out and then return something from that query. So that's essentially all this queries is doing, because we've got a with step there. That's all that's doing. If I hit extract namespaces, it will go through, it will run that query in the background. And you can see that from that fragment, we've now got music and ind as prefixes.
Yeah, I guess the music as the prefix for the vocabulary, the music terminology, and indiv just as a way of identifying individuals. So.
Cool. Yeah, so then we go back into the preview mode, and then I take the URL again, and then do it in GraphView. So now you can see that the NS0 has now been replaced with music. So now we've got music_artist, and then the values that come from that are now also prefixed as well.
Cool. Yeah, so that's basically what we're doing here. We're not loading any data in Neo4j yet, so we're previewing. We're seeing what would that look like if we were to persist it, and that's typically the way. I mean, what you would do. I mean, you say, well, is that the graph that I want to keep in Neo? Well, maybe I can just, without any change, just take the current configuration and go to the input and just run it. But maybe, you know, just to show all the options, all the features in the app, maybe we want to say, well, let's say we want to look at the case where we don't need to persist all the URIs. We want to actually define some mappings and transform the way that the RDF data is persisted into Neo4j. So how would we do that?
Yeah, and so for that, we've got the mapping screen. What that allows you to do is to essentially select a namespace, and then you can create the mappings from there. If we select music, for example, so then this gives you the form which will then create the cipher statement for you. So what would be a good thing to do here?
Well, I mean, we're just going to kind of play with it. So let's say, well, one of the things that was defined in the schema in the RDF data was band. I think the notion of a band. So band, artist, and there's the member relationship, right? So let's go and define aliases for all that. So if we say, well, I want band to be called music band, for example, I don't know, just so that would be at the top is the schema, the public schema element, and at the bottom is the persisted, the Neo4j one. So let's call the top one band, and let's rename it to music band, for example.
But band that's in lowercase, right? Or
well, that we have to do both, because the capital one is the type, so it's on the top, just next to Beatles is, and the lowercase is actually the relationship between I think it's between the album and the band. Okay. So yeah, and this is of course case sensitive because it's part of the URI. So yeah, if you set in the graph element name something, maybe music band or yeah. Perfect, we can define that mapping. And then we can say also, I don't know, let's pick the member, was it member? Yeah, member. Let's use kind of a Neo4j more style is member of or something like that. Yeah, there you go. And you can add that mapping as well. You can also rename properties. So for example, the name of the band, you can, or yeah, I mean, just play with some others. Maybe we can take a, or we can now let's do the let's look at the link between the one that connects I think it was albums to bands, or it's the band with a small b, isn't it? So is it? No, it's artist. Sorry, artist.
Okay.
The small one. Small. There you go. That's the one. So you want to map, for example, artist, and we want to call it. That's the one that's created by, or that's the one that connects the album with the author.
Mm-hmm.
Yeah.
Okay.
Well, let's just do that, for example. But we can go on, and actually this simplifies it because you can do it through a UI, but you can obviously script that if you have a large model that you want to map.
Yeah. And one thing that's bugging me is the length. Yeah. That should definitely be duration rather than length. So I'm going to stick
there.
There
you go. Exactly. That's exactly the kind of thing that you face when you're importing data. Duration in seconds. Exactly.
Cool. And again, we could do the same thing with the individuals as well.
As many namespaces as you have.
So you can do that.
So now if we want to see what the effect of this mapping would be, we have to go back to the config and say, well, because if you remember, we set it to the default, which was shorten. Mm-hmm. We want to say map. So map means applied transformations that we've defined. Yep. And so if we should be able to do that because the graph's still empty, hopefully. Yeah. So we have not imported data yet. So now we have it set to map. That's good. And if you go back to the preview, now it should hopefully show the same data. Well, in triples are the same. In the graph, we should see some differences later. So we see the member of, and we see music band instead of band. If you click probably on the album, no, it was on the song, you will see the duration in seconds. So that's basically. So here we could iterate until we're happy with the model that we're building, and then you get to a point where you say, well, that's fine. I want to now persist that in Neo4j. So let's go for it. Let's now take the URL and move from the preview to the import.
Perfect. So this is where the magic happens. So far I've only been using the fetch procedure, but what the what the app allows you to do as well is to use the inline. So you can either copy and paste, or you can upload a file from your hard drive. So I've downloaded these files. So I've got this TTL file here. So I can click open, and then that will load that in for me. So this is the procedure that would run. So we've got everything inline there, and it's in turtle format. If I hit import data, then it will give me the results. So this is telling me that the termination status is okay, everything is fine. It managed to load 51 triples from the file. Of those 51, all 51 there were passed. And then there's some extra information that may or may not be there based on the call. So now what we can do is if we open up Neo4j browser, we can then actually see it inside Neo4j browser itself. So for example, if I just click on the star here to open up everything, so we can now see that everything is inside Neo4j. So if I say for a music band, for example, let's give it the name for the resource. Let's give everything a name. So now we can see that we have Ronnie Wood, who's a member of the Rolling Stones. There's a mappings there from oh, sorry, that's the namespace mapping. We don't need to worry too much about that. Yeah. And then we have the Beatles, which has the 4 members, and then there was the White Album, which was released by them.
I think the model, it has the album, and then it has one song, and it's linked to the authors as well. So there's kind of a double link to John Lennon and Paul McCartney. Yeah. But that should reflect pretty much what we were seeing in the app. So that's, the idea is once you've got to the model that you want to build, you run it, and of course that can import large volumes of RDF. So that will populate your graph. So I think that kind of covers pretty much the import side of things, right?
Yep.
So what do you think, Adam? Should we look at the export or maybe the validations? What do you have?
So let's take a look at the export first. So that's the easiest one. What the export endpoint does essentially. So I remember earlier we mapped some endpoints to RDF inside the config file. So now what you can do from this area of the app is you can take one of the URIs of one of the resources, and then essentially perform a GET request.
Actually, let me be a bit annoying, Adam, if you don't mind. So can we, because one of the interesting things, because now we've applied a mapping, so we kind of transformed and lost some of the RDF data in the process. So would it be okay if we just quickly empty the graph, reset it, and just show how we can regenerate exactly the RDF that we loaded? I mean, sure. So let's do just detach delete of the whole graph if you want in, or
Yeah, so I guess there are two ways to do this, right? So there's this delete screen which will allow you to delete the data from an RDF file. For example, if I take that URL, I paste it back in there, and then run the procedure. I've just realized that's named wrong, so that's a bug on my point. But yeah, so we can delete all of the data from a particular RDF file just by running that procedure. So this is deleted 51 triples. So I need to delete the graph config as well.
Well, you can now the graph is empty, so you can just reset it. So it should be fine. So you can go to the config and maybe set all the defaults and hit create, and that should probably override it to the. Yep. So we see it's back to shorten and everything. So perfect. Yeah. So if we just do the import without any changes, I mean without the names, with the namespaces that we have, which is fine, that's not an issue.
Yep.
Oh, it looks like there's a couple of triples difference between the one in. Maybe I've added a couple of things in the. Doesn't matter. Okay, so now we have the data imported, right?
Yeah.
And yeah, if we go to the export, we can. Take, for example, from the original RDF file.
So we can take. So do we take the Beatles? Is that right? The underscore Beatles, or
that should be.
Paul McCartney, for example.
Yeah, you can. You need to replace the IND to form the full URI with the prefix definition at the top.
Yeah. Okay.
So that would be.
So take the prefix.
Yeah.
And then Paul McCartney.
There you go. And there you go. So you get exactly the same triples about Paul McCartney that we got there. So we see that he's an artist, and it's described according to the music vocabulary, exactly the same. We have the name. We have the fact that he's a member of the Beatles. So these what the describe method returns is all the statements that all the properties about that node and all the incoming or outgoing relationships. So you see that he appears as the author of Helter Skelter, but he's also a member of the Beatles. And if there was outgoing connections, they would show here as well. So it's actually the equivalent of the describe method in the Sparkle API as well, the Sparkle protocol. Sorry. Yeah. So cool. That's that shows the export as well. I mean, probably we'll skip it today, but there's a couple of other options for export. So here you can export by unique identifier. So in this case, you export by URI or by node ID if you have a property graph. But you can also, I mentioned before, you can run Cipher query and get the output serialized as RDF. That's another option. And you can do search by label, property value. So there's a couple of other options that will kind of over time, I guess, add to the app. But in this first version, it just covers the describe. So cool.
Cool. So I guess the only thing left now is the validation side. So the important shackle files.
Yeah. So that's just a couple of words on what it is. So that's a new feature in 4.0. And it's, again, one of these things that the community was asking, and it seems to be one of the ways in which people want to use ontologies and what modern ontologies, constraint definitions in Shackle. So that's what Shackle is. It's a vocabulary that makes it possible for you. We're going to have a look at an example now to define what your graph should look like in terms of shapes, right? These type of nodes will have these type of properties with these values, with these constraints. They will link in these or that other way. And you can basically automate the validation of a model. So we can check that there's no violations of these constraints in an existing graph. But there's another mode of operation which is pretty interesting as well, which is the transactional one. So you can have it applied as you write data to Neo4j, and then the transaction will be rolled back if there's any violation of these constraints. So it can not only check an existing graph, but it can help you keeping it consistent over time. So I guess we're going to look at one example of the first, right? So yeah, again, I don't know how many shackle experts are in the session here, but I think it's not too bad, right? So we see that there's in this example there, we're defining a shape that applies to a class which is band. So is a shape that applies to the nodes of type band, and we're essentially saying that they will have a property which is name, right? That's what's in the path. And we're specifying the cardinality. We say that the band will have a minimum of one name and a maximum of one name. And also the type, the data type of that property is going to have to be a string. And something similar for the member relationship. Notice that RDF does not make a difference between what's a property and what's a relationship in a graph. I mean, Neo4j is very different because the properties are part of the internal structure of a node, whereas relationship connect them to other nodes. In RDF, they're all predicates in a triple, so but doesn't matter. So in the second one, we're saying that the member property, in our case, is a relationship that connects the band with the members, has to also some cardinality constraints. So just for the test today, we're saying that a band only can have up to 4 members, right? Just to make it fail on the stones, and a minimum of 1. But you can of course play with these values. And also, quite importantly, there we're saying that the target value of the nodes, sorry, the target value, the node at the other end of the relationship is going to have to be of type artist. So basically, every member of a band is going to have to be an artist. If that's not the case, that will throw a validation error. So this is one of the things that you can do with Shackle. There's many more. We cover a significant portion of it in Neosemantics. Well, let's see what that looks like. So.
Cool, and yeah, this is an interesting thing as well, because this is something that we don't really do in Neo4j itself at the moment. So it might be something that makes me want to use Neosemantics for my next project. So
there you go.
Cool. Cool. So I've got this one downloaded, so I'll upload that. And so then we can see below. So this is the procedure. So again, we've got the fetch and we've got the import. Sorry, the inline. So with this procedure, with this shackle value in this turtle format, I can then load the constraints. And then once you've done that, it will tell you, or give you a list of all the constraints that are listed in the.
Yeah, which might be maybe more kind of human readable in a way, because basically you're seeing there for this type, for this category in the graph, this property, you have this constraint. And what's happened here is it's kind of compiled these constraints into an executable form. So you will not see these RDF like we did before with these RDF as nodes and relationships. So we're kind of keeping in a separate sort of bucket in an executable form, so that we can now run these on your actual data. Mm-hmm. But yeah, so that's the next step, I guess.
Cool. Yeah. So we've got those constraints now set up. They're stored in the database. So next thing we can do is we can run a validation procedure. So n10s.validation.shackle.validate. And then that will run the validation. It will show any of the violations of that of the constraints that you've just added. And so you can see, for example, the focus node. So the node in question, which has the validation issue, is the stones, which has a type of band. The shape that is that's invalidating the constraint is the max count constraint, and then it's the path of that is the member. So essentially, this is saying that it's a there are too many members, so you can see from the result message. So it's an unacceptable cardinality, so there are 5 instead of between 1 and 4, which is what we've defined above, and the severity of that is a violation.
Yeah, again, there's more elements that we're probably not covering here today, but yeah, the output of a shackle validation can also be serialized as RDF, and that's why a lot of these information to a user, all we need really is the last column, right? Is in that property there's this violation, but all that's required if we want to produce a proper RDF report, to be fully shackle compliant. But yeah, the idea is that this has been run as a as a batch on the whole graph, and but there's the other mode of operation that I guess we won't cover today that can also be applied as you update the graph. So yeah, I think that was well, and of course we could play, but I think we're gonna stop it here because it's I don't know if there's anything left that we haven't covered, because in the end we even did the delete, export, import. Anything else there?
Yeah, I think that's everything that I built. I'd say the only other thing I'd say to the people that are watching is that if you do use this app, on the bottom of every page, there's a little widget there that asks you whether the page is helpful or not. If you find it useful, you give it a thumbs up. If you don't, then please give us some feedback, so you can say what is wrong, why it's wrong, and you can give us some feedback on how to improve it.
That is great. Well, thank you very much. I don't know if it's worth me. I was going to just maybe if I can take control of the screen and
yeah,
and maybe just show the last slide to present the link to the. Let me just here a link to the community, because of course, you know, as you use it, you might want to share what you're doing. You might want to exchange experiences, and that's what the community is for. So let me. Can get the link down there. Well, basically community.neo4j.com, and there is a section on linked data, RDF, etc., etc., and you will find plenty of content there. And please do share and tell us what you would like it to. I mean, how would you like it to evolve, and so on and so forth. So again, I mentioned the code is in GitHub, and contributions are more than welcome.